Welcome to Fronds in Low Places, with apologies to Garth Brooks and the songwriters. When most divers think of giant kelp, Macrocystis pyrifera, their thoughts turn to the sky, or the ocean surface. There the extensive canopy of this seaweed extends outward to capture the rays of the sun to power photosynthesis and produce food not only for their own growth, but for the myriad other critters that live in the kelp forests. It is the awe-inspiring growth of the giant kelp up through the water column and in the canopy that inspires divers to experience them firsthand. However, as a kelp forest ecologist, I have to think of giant kelp in two completely different ways. Just like the mighty oak tree begins from a small acorn, giant kelp starts out as microscopic spores on the ocean floor that develop into tiny male and female gametophyte or sexually reproducing stages. Once fertilization occurs between them, the new sporophyte, or asexually reproducing generation, begins its surge toward the surface where it can gather more sunlight. The structures making this journey are known as fronds. A kelp frond is comprised of a stem-like stipe, the leaf-like blades, and the float bulbs or pneumatocysts on each blade. Of course, this is just like the American dream, starting at the bottom and working their way to the top, like my grandfather did. So let's start at the beginning. But which comes first, the chicken or the egg? The sporophyte or the gametophyte? Not an easy choice to make, but I do like starting at the bottom. Here, just above the giant kelp's holdfast, are clusters of blades known as sporophylls that produce the spores from which giants grow. A single giant kelp sporophyte may release as many as 500,000 spores an hour. These tiny spores may travel in the currents a bit, but most fall close to their parent. These spores have half the number of chromosomes of the parent, just like human sperm and eggs. To establish the complete complement of chromosomes requires fertilization in both cases. The tiny spores grow into male and female sexual stages known as gametophytes. They may become reproductive within a few weeks or stay in a vegetative state for up to a year waiting for the right conditions. Just like in a forest of trees, if the kelp canopy opens up because of the death of a sporophyte due to age or environmental conditions, including low nutrients or storms, sunlight reaches the bottom and triggers activity. The male gametophytes then swim to the nearby ladies and fertilize them. Thus, the giant kelp benefits from possible genetic recombination just like we humans and other sexually reproducing species do. The fertilized embryo begins developing on top of the female gametophyte. Initially, one blade appears, but then splits into at least two blades. The initial growth of the sporophyte thus begins at the ocean floor. Here, conditions may be quite different from those experienced by the mature sporophyte, which has most of its biomass in the upper layers and ocean surface. One obvious example of the differences in environmental factors is light. Mature kelp reaches the surface in order to maximize its capture of sunlight. In doing so, the canopy that develops exists in a high-light environment. However, it shades out the lower portions of the water column and thus restricts light for other native seaweeds and its own kiddies. Storm exposure also differs for the mature sporophyte and the tiny gametophyte on the bottom. Ecologically, the tiny gametophytes are subject to potentially intense feeding by snails, sea urchins, and other critters. Given their small size, such actions are almost always fatal. The growth region of a kelp frond is known as the apical meristem. It is formed when the terminal or end blade starts splitting into new blades. Of course, this begins near the holdfast and continues as the frond grows toward the surface. These growth regions are often quite intriguing and frequently photographed by divers. Under normal conditions, the kelp holdfast securing the sporophyte to the bottom is perennial. It may survive anywhere from 3 to 8 years, depending on environmental conditions. Severe storms may rip out the entire sporophyte, including the holdfast, which may then drift with the ocean currents. In fact, many invertebrates, and even some fish, are known to disperse to new locations by drifting on or with these kelp rafts. Since holdfasts attach to hard substrate near the bottom, they are usually bathed in the cooler waters at depth. Individual kelp fronds and entire canopies may disappear during periods of unusually high temperature, but the holdfast generally persists. However, the extreme water temperatures the past 12 months actually extended to deeper water and killed off many of the holdfasts. Under such situations, new kelp growth may be impossible, although some holdfasts survive to sprout new fronds again. Even under normal conditions, kelp fronds do not last forever. Although it depends on a range of environmental conditions, the average duration of a single kelp frond is somewhere around 6 months. Just like yours truly, they age over time. As a meristem creates new kelp blades, they are clean and free of encrusting critters. Their photosynthetic efficiency is high, and that helps promote new growth. Since the new blades are still growing, they do not afford a stable substrate for attached critters. However, once growth stops, encrusting invertebrates can attach to the now stable platform. These often include bryozoan colonies like membranipara, the Jack Frost bryozoan, and bushy hydroid colonies. Other invertebrates often attach to the kelp blade at this point, such as the tiny sea anemone Bunodiopsis and even young sea stars. These critters attract predators of their own, and soon the kelp blade becomes an ecosystem in itself. The impact of the encrusters reduces the efficiency of the blade's photosynthesis and accelerates the death of the blade and eventually the entire frond. Blades start to disappear from the stipes, and the nematocysts decay and disappear as well, leaving just the tough stipe. At this point, giant kelp becomes truly dangerous. Well, kind of. These denuded stipes can entangle divers and may even form webs to entrap them if they are not careful. Just teasing, kids. Of course, well before the death of the older fronds, new ones begin growing from the holdfast. This cycle continues until the demise of the holdfast itself, upon which time new kelp appears with young blades and fronds to replace the old. So next time you dive a healthy kelp forest, don't just look up at the wondrous canopy and the sunlight streaming down through it. Think of where it all begins, with the fronds in low places.